All right, so let's get into it. We're going to talk about something called LangGraph, which is, well, it's a framework that's basically changing the game for how AI applications are built. It tackles this huge problem in AI, how to build apps that can think in loops and make decisions, not just follow a straight, simple path. And that shift, it's what takes AI from being a cool prototype to a powerful, production-ready tool. Okay, let's start with something I'm sure you've run into. You're talking to an AI assistant, maybe getting some really useful stuff, and then you ask a follow-up question, and it has absolutely no idea what you're talking about, right? It's like the conversation never happened. It feels clunky, super limited, and honestly, it's just plain frustrating. So why does that happen? Well, it usually comes down to how these things are built. Most AI is put together in these simple linear chains. You can picture it like a one-way street. You give a prompt, it goes to the language model, and you get an output. End of story. But real-world problems, they're never that simple, are they? So these basic agents, they have no memory, they make a lot of mistakes, and they often just get stuck until a person steps in. But what if an AI could actually remember things? What if it could handle loops, make decisions on the fly, just like we do? Imagine it could navigate a whole city map instead of just driving down one straight road. Well, that's exactly where LangGraph comes into the picture. It's a totally new map for building AI. And this really gets to the heart of the big shift here. You've got LangChain, which is awesome for those simple straight-line tasks. It's like a basic flowchart. But then you have LangGraph, and that introduces this dynamic, graph-based flow. It's not a simple flowchart anymore. It's more like a full-blown control panel. It's built for handling really complex logic and making apps that are ready for the real world. Okay, so how does this graph-based approach actually work? How do you build one of these complex maps for an AI? Well, it really just boils down to a few core building blocks that fit together perfectly. So first, you have what's called the state, and this is basically the agent's memory. The absolute best way to picture this is like a big whiteboard in a meeting room. Everyone in the room, every part of the process, can walk up, see what's written on it, add their own notes, and erase things. It's this shared space that keeps the entire system on the same page. All right, next up we have nodes. And if the state is the whiteboard, then the nodes are the specialized workers in the room. Each node is like a little function that does one specific job. It looks at the whiteboard, does its task based on what it sees, and then maybe adds its own update to the board for the next worker to see. And then you have the edges. These are the paths that connect all the different workers or nodes. They're what determine the flow of work. But here's the really cool part, the magic, really. The edges can be conditional. They act like a traffic cop. They look at the whiteboard, the current state, and decide, okay, based on this, should we go to this worker next or that one? That's how you get loops in real decision-making. Now, let's see how all those pieces, the state, nodes, and edges, come together. In this little workflow here, you've got a node called check_new emails. And see those connections? Those are the conditional edges. If it finds new emails, the edge says continue and sends it over to another node to draft replies. If not, it just hits the end edge. It's a simple little loop, but it's powerful. It creates an agent that can just sit there and continuously check for new work to do. And this slide gives you a peek at what that map looks like when you're actually writing the code. You can see developers are basically drawing that diagram, but with code. They add the nodes, the functions, and then they define those all-important edges that tell the system where to go next based on what's happening. This is how you give the AI agent really precise, fine-grained control over what it does and when. Okay, so this isn't just some academic theory. This is happening right now. So let's move on and take a look at some of the absolutely incredible things people are building with LangGraph out in the real world. I mean, developers are building some seriously advanced agents that are way, way beyond a simple chatbot. We're talking about smart SQL agents that you can ask database questions to in just plain English, or web research agents that can go out, gather information, and write a whole structured article all on their own. And get this, even agents that can write code, test it themselves, find their own mistakes, and then fix them. That's a whole other level. This kind of power and flexibility is why one expert, Dilip Kumar Pandya over at ZoomInfo, called LangGraph an operating system for AI agents. And that's such a perfect way to describe it, right? It's not just running a single program, it's the OS that's managing and orchestrating a whole team of different AI agents working together. And that idea of a team is absolutely central here.
because LangGraph is amazing at making multiple agents collaborate. You can literally set it up so one agent writes some code, and a second agent's entire job is to review that code and test it. If the reviewer finds a bug, the workflow loops right back to the first agent to fix it. It's a self-improving cycle. It's like having a built-in quality assurance department that's all AI.
And this is why huge companies are already all in on this. We're not talking about experiments. Uber is using LangGraph to automatically create unit tests for their code. Replit uses it to help power their real-time code generation. AppFolio built an AI copilot that's literally saving property managers more than 10 hours a week. So yeah, this isn't just a toy. It's scalable, it's reliable, and it's solving real business problems.
But here's a really important point. This doesn't just cut people out of the equation. LangGraph was designed with human in-the-loop capabilities built right in. That means you can design your workflow to pause at any critical point, send an alert to a person, and wait for them to review and approve the work before it moves on. It's an absolutely essential feature for making sure you have control and accuracy, especially when the stakes are high.
So, when you put all of this together, what you get is a framework that finally gives us the structure we need to build beyond simple little chatbots. It's the tool that lets us create truly agentic AI. And what that means is, we can build systems that can actually reason, plan out their steps, and carry out complex tasks, all while remembering what they're doing and adapting as they go. And that, of course, leads to a really fascinating question about what's next. When you have tools like LangGraph that let you build teams of AI agents that can work together, fix their own mistakes, and even collaborate with us, what kind of problems that we thought were impossible are suddenly solvable? The map has been drawn for us. Now the only question is, where are we going to go with it?